Patterson. Today we're going to work on how to read a graduated cylinder. All right, so the volume is the amount of space that matter takes up. So if you look at my video that I did over volume, how to solve for irregular objects, fluids, and cubes, I kind of discussed volume and what makes up volume. So I'll try to link that down in the bottom for you guys to go back and look at if you want to. But volume is the amount of space matter takes up. It's going to be atoms, it's going to be molecules that cause that to happen. So the volume of a fluid can be found with a graduated cylinder. So these are these cylinder-like objects that you'll find in labs. They can be plastic, they can be glass, but you're going to see lines and you're going to see these numbers on them, and that's allowing you to be able to determine the volume of that fluid. Graduates, these are the marked and unmarked lines on the cylinder. So this line here is a graduate. This is considered really a subgraduate, but this is a graduate. All these are graduate lines. These all mean something. I can even do in between lines, can mean something else also. So here I have the bold numbers. These are graduates, so 40, 30, 20, 10, 50. These are your big graduate numbers. The small lines in between, these are subgraduates. So these are kind of like the smaller numbers within that volume. So graduate cylinders have many different graduate values. So here you can see I have a lot of lines in between the 8 and the 9. And here I have just a few. So this is going to give me different numbers. This is going to mean something different than what I have over here. So to calculate the value graduates, it's really very simple. You're going to find the difference between the numbered graduates by subtracting one graduate from the highest graduate value. So what that means is here I have my graduate, which is my big numbers, 200, and down here I have 100. I'm going to subtract those two numbers. When I subtract those two numbers, I get 100 milliliters. Next, what I'm going to do is I'm going to count the lines that are between those graduates. So I'm counting my subgraduates. You never count the first step. If you're going downstairs, you don't count the step you're standing on. You count the next step down. So you don't count this first one. So you count from here. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is my 10th step, or this is my 10th line. I have to write that number down. So I have 10 lines that go with it. Next, what I'm going to do is I'm going to divide the difference between the graduates and the number of steps or the number of lines that I have. This is going to tell me what my volume is per line. So I take 100 milliliters. That was what I figured out in step 1. My number of lines, I had 10 lines. That was step 2. I divide those. It means that each of these lines represents 10 milliliters. So if I wanted to look, I could say this is 100, this is 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. So each of these lines go up or down by 10 milliliters. If I wanted to know what this one was, it would be 90, that would be 80. So let's practice. I just want you to tell me how much increments, what does each line value represent? So you can pick any number. You could pick 6 and 5, you could pick 7 and 6. It doesn't matter. You're going to get the same number. So here I pick 7 and 6. I'm going to subtract those two numbers and I'm going to get 1. Then I have to count how many lines I've got. Remember, you don't count that first step. You count the steps above it, and I have 10 lines. So I divide those. So 1 milliliter divided by 10 lines. Each of these lines represent 0.1 milliliter. So what that means is this is 6.0, 6.1, 6.2, 6.3, 6.4, 6.5, 6.6, 6.7, 6.8, 6.9, 7.0. So all of these lines go up by 0.1. So let's look at this one. I want you to tell me the increments or the value for each line. So if you want, you can pause and kind of see if you can figure it out yourself. So I subtract my two graduates. My two graduate numbers is 9 and 8. I'm going to count how many steps I have. I have 10 lines. I go up 10 steps. I'm going to divide my number milliliters into 10 lines. So each of these lines represent 0.1 milliliters. Okay, you can practice with this one. Pause. I'm going to take my two graduate numbers is 1,000 and 800. I subtract that and now I've got 200 milliliters. Next step is I'm going to count how many lines, how many steps I need to step up to get there. And I have 10 lines. So I divide 200 milliliters divided by 10 lines. Each of them represents 20 milliliters. So what that's saying is this is 800, 820, 840, 860, 880, 900, so on and so forth. Okay, practice on this one. I'm going to subtract 2 and 1. That gives me 1 milliliter. I'm going to count my lines. That gives me 5 lines. So 1 divided by 5 is 0.2. So that means this is 1. This is going to be 1.2, 1.4, 1.6, 1.8, 2.0. So each of these goes up by 0.2. Okay, so let's practice with this one. I have this graduated cylinder. I'm going to take 0.3, subtract it from 0.2. That gives me 0.1. I'm going to count my lines, and I have 10 lines. I'm going to divide those two, so 0.1 divided by 10 gives me 0.01 milliliters. What I notice with students is sometimes they try to rush through this real quick. Just real quick do the math because a lot of them will forget this 0 and it will mess stuff up. So what this means is that each of these lines is 0.01. So this is 0.2. This line here would be 0.21, 0.22, 0.23, 0.24, 0.25. This would be 0.31. This would be 0.19, 0.18. So all of these go down by 0.01. The meniscus is the curve that is in the fluid. Anything that is water-based is basically going to have this type of fluid. When you're looking at a meniscus, you want to always look at the bottom of the meniscus. You have adhesion and cohesion working on the sides, and it doesn't give you a true measurement. So you always want to look at the bottom of it. Now, some things like mercury can bow up, but water will bow down. So mercury can have a different property inside a tube. When you're looking at a meniscus, you want to look at it straight on. So you want to try to get down to the level of the meniscus. When you're looking at it this way, you can have a low reading. If you're looking at it from up top, you can have too high of a reading. So you want to kind of get down to the level. Don't lift up the graduated cylinder, look at it. You want to kind of squat down. Make sure you're wearing goggles. You want eye protection when you're dealing with fluids. And you're going to squat down to look at it on a level surface. So how to find the volume of a graduated cylinder. So first you need to find your graduate value, and that's what we've done. You subtract these two numbers, you count how many lines you've got, and you divide by that. That gives you your graduate value. Once you know what those lines mean, then it's real simple to figure out what this level of fluid is at. So here I do my first one. I have 7 minus 6. I'm going to divide by 10 because I have 10 lines. So each of these lines represent 0.1. So my fluid is here. So my line I need to count to is here. So each line represents 0.1. So this is 6, 6.1, 6.2, 6.3, 6.4, 6.5. So this volume is at 6.5 milliliters. Okay, if you want to try this one, go ahead. I have an arrow showing where the meniscus is. So the first thing, you're going to find your increments. What does each line value represent? I'm going to subtract 9 from 8. I'm going to divide by 10. And each line represents 0.1 milliliters. Next, I'm going to count up. That's 8, 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7. So my volume for this fluid is 8.7 milliliters. I'll let you practice this one. I subtract 1,000 from 800. That gives me 20 milliliters, so each line represents 20 milliliters. I count up 820, 840, 860, 880, 900, 920, 940. So my fluid is 940 milliliters. Okay, try this one. 3 minus 2 is 1 divided by 10. My lines represent 0.1 milliliters. Now I'm going to find my fluid. I don't have a 1 down here, so I can't count up, but I can easily count down. So this is 2.0, 1.9, 1.8, 1.7, 1.6, 1.5. So my fluid for this graduated cylinder is 1.5 milliliters. Okay, I'll let you practice this one on your own. I take 0.3 minus 0.2, divide by 10. Each of these lines represent 0.01 milliliters. So here you can see I have 2 or 0.2. You can think of it as 0.20. This is 0.21, 0.22. So you could say 0.22 milliliters. I would probably go out if you want to be more accurate. It's not necessarily on that 2. So you could really kind of say it's 0.218, 0.217. You can kind of get out to that thousandth if you wanted to be more accurate. But for me, looking at this, 0.22 is a good enough estimate for that. All right, that's all I have today on how to read a graduated cylinder. If this was helpful and you think this will help you in your class, I'd appreciate if you guys would subscribe. You guys have a great day.